Inverse functions. What happened? Well, your voice is so different today. What happened?
X and Y switch.
Yeah. Inverse functions, x and y values just switch. That's it. That's all it is. Should we go to 7.5?
Sure.
All that happens here is that your x and y values switch when we're talking about inverses. So that means when we're trying to find inverse relations with equations, in order to find the inverse relationship in an equation then, all you have to do is exchange the x and y's and resolve the equation for y. So to find the inverse of a relationship that is given with the equation that has x and y in it, all you do is switch the x and y and then solve for y. So if my original equation is y equals 2x minus 4, the inverse of that equation would be, well, x equals 2y minus 4. See how I just flip-flop the x and y values? Solve that for y. What do you do? Add 4. And divide by 2. There's your inverse. X over 2 plus 2 is y. That's how you find the inverse of an equation. Not so scary to start with? It's still a bit. All we're doing is flip-flop the x's and y's. So, take a minute, flip-flop the x and y's and resolve this. Alright. Remember, first step, exchange x and y. So x is negative 2/3 y plus 6. Subtract 6. Multiply by the reciprocal. And then just distribute. Negative 3/2 x plus 9. And there's your inverse. Yes, sir. You're not changing, not doing parallel perpendicular here. Remember, when you're just multiplying by the reciprocal, just multiply it. Not multiplying by the opposite reciprocal. You're not trying to find slopes. Okay. That's a very common mistake, so try not to do that. Okay. Now, does anything change if this said f of x equals that? Because remember, what is f of x a fancy way of writing? Y equals. Okay. So if you see f of x or y equals, it means they kind of mean the same thing. They're kind of synonymous with one another. So you can treat it that way. Okay? So let's go a step further. In order to tell if something is an inverse, there's a lot of writing here for something that's very simple to understand. In order to tell if something is an inverse, or verify that something is an inverse, take the original equation and the given inverse, substitute one into the other, and the other back in the other. If you get the same answer, and that answer is x, they're inverses. I know I'm getting the looks of what? How do you write that out? You write it out like this. You got your two functions. F of x is 2x minus 4, and the given inverse is f to the negative 1. Remember, the inverse of f is 1/2 x plus 2. Now, to verify that this is true, to verify that these are, in fact, inverses of one another, you take this equation, substitute into here. 2 times 1/2 x plus 2 minus 4. Simplify. I get x. Right? Then take this equation and substitute into here. Simplify once again. Did Did you get the same answer? Is that answer X? That means that those are, in fact, inverses of one another. That just means that those two are actually inverses of one another. When you substitute into each other and you simplify out and you get the exact same result, X, that means that they are inverses. That's what that looks like. Now, the book will rewrite it a little bit differently. It'll say f of x and inverse of f of x, or it'll say verify f of x and g of x are inverses of one another. So just have to read into it how it's given to you. The next example I have is in fact written that way, f of x and g of x. I want to verify that f of x and g of x are inverses of one another, where f of x is 8x cubed, and g of x is x to the 1/3 divided by 2. So in order to tell if they are going to be inverses, what is f? Bless you. F of g of x and g of f of x. What I'm doing then is substitute, like I said earlier, substituting into each other, simplifying to see if you get the same answer. And that same answer has to be x. So f, let's see, so it's x to the 1/3 over 2 cubed. What does the 1/3 power mean again, guys? Cube root. Cube root cube is what? Yeah. So the cube root of x cubed is x. So this becomes 8x. And what's 2 cubed? 8 over 8 is? Your answer is? Okay. Do the same thing on the other side. F of g of x. So I have 8x cubed to the 1/3 over 2. Once again, the 1/3 power means cube root. What's the cube root of 8? 2. And the cube root of x cubed? X. So you get 2x over 2. Lo and behold, are those two inverses of one another? Does that make more sense when you see it written as f and g? I think so too. I think so too. I just want to give you the idea that you take one equation, substitute in the other, then do the same thing on the other side. If you simplify out, you get x for both of them. They are inverses. Okay. Inverses really aren't scary. Now, we've already answered this question. Does anything change when you see f of x equals something when you try to find an inverse? Because remember, f of x means the same thing in our minds as y equals. So this is the same idea as y equals x squared. Okay. So it wants you to figure out what the inverse of y equals x squared is. Once again, swap x and y. And then how do you undo square root? Now, square root of y squared is what? Or plus minus y. See how I'm going to take the square root and there's an equal sign? So I have to do this. You agree? So then this side is that. In order to move that plus minus over here, what do? No. This is plus or minus 1y, right? To get y by itself, why do you just divide by plus or minus 1y? Or plus or minus 1, I should say. Okay. And then lastly, I don't know if you noticed this, It's just looking for one set of values when x values are greater than or equal to 0. So should I be looking at positive values, negative values, or both values? Positive. So sometimes the problem will ask you to do that. Okay. Sometimes the problem will ask you to do that. Okay. And those are just those little bits and pieces that you'll find as you go further and further into these things. Okay. Remember your rules for exponents don't change. To undo squaring, you take the square root. To undo fourth power, you take the fourth root. To undo the sixth power, you take the sixth root, and so on and so forth. Okay. So let's use our calculators for some of this stuff then. I have the function f of x is 1/2 x cubed minus 2. What I want to do is I want to tell whether or not the inverse of this function will indeed be a function itself. Do you guys remember how to tell if a graph is a function? The vertical line test. So if something passes the vertical line test, that means you can go all the way across with the vertical line and it touches it only in one spot, right? At least only at most one spot. Now, if it doesn't pass it, then we knew it wasn't a function. The horizontal line test is a little bit different. The horizontal line test is going left to right. Now, if you take a graph of any equation, the original equation, if it does not pass the horizontal test, then its inverse won't pass the vertical line test. Therefore, it won't be a function. Yeah. But what? I can't. Oh, the axis on. Go to. You got it first. You got it on? Yeah. Thanks, buddy. So let's think of a real easy equation or a real easy graph. What's that? That's a parabola. Is it up like a cup or down like a frown?
Up like a cup.
It's up like a cup. Does that pass the vertical line test? Yes, it passes the vertical line test, okay? Does it pass the horizontal line test? No, it doesn't pass the horizontal line test because if you get the inverse of this, that's the inverse of a parabola. It's not a function because now it won't pass the vertical line test. Parabola doesn't or the hyperbola doesn't pass the vertical line test. Does that make sense? We will eventually get to graphing these style conics, but just not yet. What? What?
It's just, we're going to be graphing all that?
Yeah.
So do you do like each one separately, or would it be all in the same graph?
The inverse stuff like this?
Okay.
We're actually going to have a whole chapter on conics that we're going to be graphing stuff that'll look like this eventually. We'll eventually do stuff like that as well.
What? Okay.
But that's not for a while.
But wait, those are like the asymptotes of the yeah.
But we'll worry about that later. So let's take a look at this. In your graphing calculator, I want you to substitute in into your y equals 1/2 x cubed minus 2. For all intents and purposes, since it's just 1/2, is it okay if I put 0.5 in my calculator?
Yeah.
I know. X to the third, and then what was it, minus 2? So when you look at this, you wind up with, you got it there. Now you're doing something wrong. What do you do? Your window range. Your maximum was lower than the minimum. So in this case here, when you graph that, you wind up with that. Now, this may look like it won't pass the horizontal test here, but what's happening is as you get closer and closer to -2, this curve is approaching it, then it changes direction. So it does pass the horizontal line test. So that means that the inverse of this function, when you do the inverse, it would look like that. but we'll learn that tomorrow. So it will pass it. So since it does pass that horizontal line test, what I want to do now is just figure out, well, what is the inverse of this? If it does pass that inverse, that horizontal line test, let's pass and see what the function is. So the inverse of this, remember, in order to solve for that, we have y equals 1/2 x cubed minus 2. The inverse of that would be x equals 1/2 y cubed minus 2. What do you do first? Good. Add 2. Now what? Yeah, what's the reciprocal of half? 2. Multiply everything by 2, you get 2x plus 4 is y cubed. And now how do you undo cubing? Cube root. And there's your inverse. Okay? You just follow like you would getting y by itself at any other point in time. You just might have to deal with some exponent rules with your cubes or your nth root stuff. Okay? But hopefully it is not too scary. All right? Let me give you one more example and I'll give you some problems. F of x is 10x cubed. What I'd like you to do is try it in your calculator to see if it passes the horizontal line test. If it passes the horizontal line test, then give me the inverse of this, please. All right, do we agree that the inverse of this will be a function? Okay, I agree. So in this case here, you have y equals 10x cubed. So that means x equals 10y cubed. Divide by 10. And then you have to take the cube root. Okay? Now when you take the cube root, you've got the cube root of x over the cube root of 10. You don't want radicals in the denominator. So you have to turn that cube root of 10 into a perfect cube. So, what's 10 cubed? 1,000. What do you have to multiply 10 by to turn it into 1,000? 100. So you multiply the top and the bottom by the cube root of 100. So now you have the cube root of 1,000, which is 10, and then the numerator is that. So once again, you have to worry about, you have to worry about the rules here with radicals in the denominator. Create that perfect cube root in the denominator. That will be the kicker out of anything on these things. You guys will do the work just fine, but you'll forget something like that. All right? So tonight what I would like you to do starts up on page 426. We'll do those two sets, please.